Okay, right, the title of this video is finding the HCF, or highest common factor, and the LCM, or lowest common multiple. Keywords are prime factors, factor tree, and Venn diagram. The objectives of the lesson are to be able to find the highest common factor and the lowest common multiple for a pair of numbers. Okay, now I'm going to start off using one method, which is usually the first method that students learn in school of how to find the highest common factor and the lowest common multiple, which is to make a list. And in doing that, these two examples, I'm also going to highlight the meaning of some of those words that were in the title page. Okay, so first of all, looking at highest common factors. Now, the word factor, basically, when we're dealing with whole numbers, is a number that goes exactly into another number. So in the example here, 9 and 15, the factors of 9 are the numbers that go exactly into 9. So I know that 1 goes into 9. I know 3 goes into 9. 3 goes into 9 exactly 3 times. And 9 goes into itself. Those are the only factors of 9. I can find the factors of 15 and list those. So again, 1 goes into every whole number. 3 goes into 15 5 times. 5 goes into 15 3 times. And 15 itself goes into 15 once. So what I've done there is I've listed the factors of 9 and I've listed the factors of 15. Now that middle word there, common, basically refers to numbers that are in both lists. So numbers which are common to both lists. And you can see straight away that 1 is in both lists. It's common to both the factors of 9 and 15. 3 is also common to that list and common to that list. Now the first word there is highest. So the highest common factor, and you've probably already guessed it, is 3, because it's the highest number that's in both the lists of factors of 9 and 15. Okay, looking at the second example, and you might want to pause the video at this stage and have a go at this yourself. So, the factors of 7. Now, I've purposely picked the number 7 to help us to recap on the meaning of one of the words we mentioned earlier, which is prime. 7 is a prime number, and you may recall that prime numbers only have 2 factors, 1 and the number itself. So 1 goes exactly into 7 and 7 goes exactly into itself. Those are the only 2 factors of 7 because it's a prime number. 10 is not a prime number, so it has more than 2 factors. So 1 goes into 10 exactly, 2, 5, and 10 itself. And you can see straight away that there is only one common factor, and it's 1. So that is also going to be the highest common factor. So the highest common factor of 7 and 10 is 1. I didn't write this for the previous one, so I'll do it now. The highest common factor of 9 and 15 is 3. Right, moving on to lowest common multiple. Now the multiple of a number, or the multiples of a number, are basically, and this is a really good way I think of remembering it, the answers to the times tables. So if you think of all your answers to each of the individual times tables, those are the multiples. So in this example, it's asking us to find the lowest common multiple of 6 and 15. The multiples of 6 are all the answers in the 6 times table. So 6, 1 times 6 is 6, 2 times 6 is 12, 18, 24, and they carry on. I'm not going to list all of them because I'm hoping to find multiples which are common to both lists. I haven't done the second list, so I'm going to list some numbers from the multiples of 15. So the multiples of 15, 1 times 15 is 15, 2 times 15 is 30, 45, and 60. And you can see that I haven't found any numbers which are in both lists. So I'm going to go back to the list of the multiples of 6, 24, 30, and you can see straight away I've now found a multiple which is common to both lists. I'm going to highlight that. So 30 is common to both lists. Now, the first word in that term, lowest common multiple. We know that these are both multiples. We know that they're common because they're the same in both lists. And we also know they're the lowest because they're the first number that we come to in each list that's common to both of them. So the lowest common multiple is 30. So we can write the LCM of 6 and 15 is 30. Again, you might want to have a go at this one and pause the video at this stage before I go through it. Right, so I list the multiples of 4. 4, 8, 12, 16, 20, and then I list the multiples of 9, 9, 18, 27, 36, 45, and I haven't found anything that's common, so I'm going to go back to the multiples of 4 and list some more of those. 24, 28, 32, 36, and there you see I've found a multiple which is common to both lists, 36, and I'll just highlight that. 36 is common to both lists, so I can write the LCM of 4 and 9 is 36. Now, quick recap. We looked at finding the highest common factor of a pair of numbers by listing the factors of each number. And we said that once we listed them, we simply look along the lists to find the highest number that's in both lists. And then we looked at the lowest common multiple and found that by listing the multiples of each number, the first number we came to that was in both lists would give us the lowest common multiple. Now that method is really good for quite small numbers like these. However, if you get some larger numbers like this, 24 and 60, there is a more efficient way of finding the LCM and HCF for larger numbers. Having said that, the previous method would still work. So we need to go back to those keywords, and the keywords that we looked at were prime factors, factor tree, and Venn diagram. So what we're going to do is, first of all, we're going to draw a factor tree to find prime factors of each number, and then we're going to use a Venn diagram to help us to find the HCF and the LCM. So let's go back to that example. The first thing we need to do is to draw a factor tree. So 24 can be broken down into its prime factors. And the way we do that is to look for any two numbers, any two factors that multiply together to give 24, and there are a few. I'm going to choose 2 and 12. And of course you could have done any other combination of factors, so you could have done 8 and 3 or 6 and 4, and you would have ended up with the same answer that I'll end up with here. So it doesn't really matter. Now as soon as you get to it, one of those is a prime number, you just mark it off because the second keyword which we talked about was prime factors. So prime factors, as soon as we get one of those, we'll just mark it off to say, well, we found a prime factor there, because that's what we're actually going to be looking for here. So the other number is not prime, so 12 can be broken down further into 2 times 6. 2 you can see straight away is prime, so I'll mark that off. 6 is not. That can be broken down into 2 times 3, and straight away you can see that 2 is prime and 3 is prime. So we found the prime factors of 24. And if we were to write these numbers down and multiply them together, I'll do them in ascending order. So the 2 from there, the 2 from there, the third 2 from there, and the 3. 2 times 2 is 4, times 2 is 8. 8 times 3 is 24. We can do the same for 60. So I'll do this a little bit faster. Again, it doesn't really matter which combination of factors you use at this stage. At the end, they should give you the same answer as I'll get here. So I'm just going to use 2 times 30. And 2 I can see straight away is prime, so I'll mark that off. 30 is not, so I can break that down some more into 2 times 15. Again, 2 is prime, and it's a good idea to keep that in your head. 2 is one of the only, is the only even prime number. Right, so 15, I can break that down some more into 3 times 5, and 3 and 5 are both prime, so I can stop there. So 3 and 5. And I've managed to break down 60 into its prime factors. So I can multiply those together. Again, I'll write them in ascending order. So 2 times 2 times 3 times 5. If you multiply those together, 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So the first step was to do a factor tree, and we did one for each number. The second step was to identify the prime factors, and we've done that. The third step involves using a Venn diagram. Now, I've got an example here of a Venn diagram, and this one has 2 circles because we're using 2 numbers, but it doesn't always have to have 2 circles. It can be more than 2, but as I said, because we're using 2 numbers, 2 will suffice. And you'd label the Venn diagram first. So the left circle, we're going to label that with 24. The right circle, I'm going to label that with 60. And these, each circle, are going to contain the factors, the prime factors for that number. So within that circle will be the prime factors for 60. Now the overlapping bit, that's going to help us to find the highest common factor. And the way we fill that overlapping bit is we look at the prime factors that are in both of these numbers. And we can write them in the middle. So 2, I can see straight away, is in both lists. So I can write it there. I only need to write it once, because by writing it there, it's actually within that circle, and it's also within that circle. I can see there's another 2 that's in both lists. So I'll pair that off. Put that again there. I need to write it once again. And then I can see that there's a 3 that's in both lists, so that's common to both lists, so I can put that inside the overlapping bit. Now, with the numbers that are remaining on the left side for 24, it's just 2. So I just put that there, because that is only a prime factor for 24 alone. And for 60, I can see it's just a 5, and that 5 is just a prime factor of 60. Whereas these are prime factors of both 60 and 24. Now, once you've got to this stage, it becomes really straightforward. The numbers in the middle, the overlapping bit, help us to find the highest common factor. And the highest common factor is found by multiplying those numbers together. So you do 2 times 2 times 3. 2 times 2 is 4, 4 times 3 is 12. So the highest common factor of 24 and 60 is 12. The LCM can be found by multiplying all of these numbers together. So 2 times 2 times 2 times 3 times 5. Now we already know what 2 times 2 times 3 is because we just worked it out for the HCF, which is 12. So we only need to write 2 times these multiplied together give 12 times 5. 2 times 12 is 24. 24 times 5 is 120. Well, you could have done the other way around because when you're multiplying it doesn't really matter. 5 times 12 is 60. 60 times 2 is 120. And that gives you the HCF of 24 and 60 and the LCM of 24 and 60 also. Okay, just one more example, slightly more challenging for you to have a go at. I'm going to pause the video and have a go, and in a couple of seconds I'll reveal the answer. Okay, the answer HCF of 180 and 84 is 12. The